Hey guys, Mrs. Matheson here. We're going to be doing Unit 3, Notes 4 on two-column proofs today. Our learning targets is I can demonstrate the ability to write a two-column proof to prove triangles are congruent. So in 3.3 we learned about proving triangles congruent. We learned about those congruent statements. And so let's just talk about what they were. I think it's on our next page actually. Our congruence theorems were side, 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 angle, angle, and angle, angle, side. Remember, there's no AAA and there's no donkeys. Then we also see here about these three little properties here that you've probably seen before. And let's just remind ourselves of them. Reflexive property. Triangle ABC is congruent to triangle ABC. Something is always congruent to itself. Our symmetric property. So if triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to ABC. So we're just saying, hey, if A is congruent to B, then B is also congruent to A. And our transitive property. If triangle ABC is congruent to DEF, and triangle DEF is congruent to GHI, then triangle ABC is congruent to GHI. So that's saying if triangle 1 is congruent to triangle 2, and triangle 2 is congruent to 3, we can cut out the middleman of triangle 2 and say 1 is congruent to 3. So we will be using mostly our reflexive property here. And symmetric and transitive we'll use very rarely, but I just want you to see them and remember those. All right, we also have a new thing that we're going to introduce, CPCTC. Corresponding parts of congruent triangles are congruent. So corresponding parts, so like if A is congruent to D, so those are corresponding parts because their angle might be in the same spot. So if the triangles are congruent, then their correspondings are congruent. So let's go ahead and get into our first proof. So our first proof here, it says given that segment NQ is congruent to PQ, and that is marked here, NQ is congruent to PQ, and NY is congruent to PY. So NY is congruent to PY. We want to prove that the two partial triangles are congruent to each other. So here's how we start a two-column proof. We have statements, and we have reasons. And we're going to make two columns. Our first statement or statements are always our given sentences. So NQ is congruent to PQ. And the reason is it's given. Now notice that I said one statement and one reason is because sometimes your statement or your reason might take up 2 lines or 3 lines, and so we keep them together by giving them numbers. We also have another given statement, and Y is congruent to PY. And this is another given statement. Now, what we have to come up with now is the in-between part. How do we take what we see in our picture and be able to prove that our two triangles are congruent? So you have to use some of your deduction skills and some of your reasoning skills for this. Well, in our first triangle here, I see that YQ is going to be in both of the triangles, this line right here. So it is in both triangle NYQ and PYQ. So we can say that it's congruent to itself. So step 3 says YQ is congruent to YQ. And our reason, well, if it's congruent to itself, that's that reflexive property. And now we need to state this. It seems kind of silly to say, hey, something's congruent to itself, but we need to state this and point this out as an obvious so that we can use it now in our triangle statements. And now if we look at this, we have proven that these two triangles are congruent because they have sides and another side that are all congruent. So step 4 is going to be triangle NYQ is congruent to triangle PYQ. And our reasoning is side, side, side. So we start with our given, we fill in any information in the middle, and then we come up with our prove statement. And our reason is not prove, we need to give a mathematical reason for it. All right, so let's look here at example 2. we're going to start right off with a statements and a reasons column. So statements and reasons. Our first ones, again, are very easy. It's RQ is parallel to TS, and it's given. And 2 is our other given statement of RQ is congruent to TS. Okay, so we need to prove that the two triangles are congruent. Now, there's a couple different orders that you can do a proof in, and I'm just going to show you one order. So now looking at our triangles, again, I see that they both share RT, and so RT is going to be congruent to RT. And our reasoning is reflexive property. Okay, so now I have two sides that are congruent to each other. So let's think about our choices are side, 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 angle, side, angle, side, angle, and angle, angle, side. Well, looking at it, I already know that two of my sides are congruent, so I'm going to cross out my options that don't use two sides. So either I need to prove that the third sides are congruent to each other, or I need to prove that their included angle is going to be congruent to each other. Well, we have RS and QT as opposite sides. So these are the other sides that we would need to be able to prove are congruent. We don't have any mathematical skills behind us that we can use to prove that these are congruent. So that's going to take side, side, side off the table. And now we need to come up with this included angle to be congruent. Now it's this angle because it is in between my two sides that are being considered congruent. Okay, so I'm going to extend out this line here and extend out my parallel lines. Now, if you notice, we have parallel lines and a transversal. And so we can use those angle relationships we've talked about in our previous unit to help us figure out how those angles are congruent. All right, so I can't just say angle R because angle R would be talking about this entire angle here. So we are going to specify angle QRT is congruent to angle, and now we have to do it the same order. So Q is going to match with STR. So why are those two angles congruent? Well, these two angles here and here have an angle relationship of alternate interior angles. So our step 4 is those two angles are congruent by alternate interior angles. And now we have proven that our two triangles are congruent. So we can go back to our proof statement and say triangle RQT is congruent to triangle TSR. And we used for our proof the side angle side. Okay, so now number 3, we have a statements and reasons column. And we are going to, again, start with our givens. So angle ATR is congruent to angle STR, and that's a given. And notice it's not marked in here. So ATR is this angle, and STR is this angle. So those angles are congruent. 2 says AT is congruent to ST, and that's another given. Now notice this time our proof is not proving that those triangles are congruent, it's proving that angles are congruent. So I'm going to tell you that there's going to be 5 steps in this one, and step 5 is going to be our prove angle S is congruent to angle A. And this is going to be corresponding parts of congruent triangles are congruent. So you need to come up with step 3 and step 4. Now, before we can prove that the angles are congruent, we need to prove that the triangles are congruent. So triangle RAT is congruent to triangle RST. And that is going to be either side, 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 angle, side, angle, side, angle, or angle, angle, side. One of these four is what you're going to use to plug in there. So I want you to come up with step 3 and then come up with why are my triangles congruent. And that is going to be to the end of our video. And have a great day.